What are reciprocal functions? They are basically 1 over the original function. Here in Pure 3, you'll have to learn 3 more trigonometric functions. But the good news is that all of them, they are the reciprocal of the functions that you've known for a long time: the sine, the cosine, and the tangent. So, starting with the cosine, the new function that you'll need to know is the second, is 1 over the cosine. The reciprocal of the sine is the cosecant. And the reciprocal of the tangent is the cotangent. Now, how do you deal with these? Now that you know what they are, you can treat any trigonometric equation that you'll find by transforming each one of these 4 into the corresponding original function, the sine, the cosine, or the tan, and then solve like you've been solving it for a long time, namely since last year. What about the shape of the functions? I've tried to draw here the shape of each one of these based on the original functions. Here on green, you have the original functions, the cosine, the sine, and the tangent. And it may seem weird here, the shape, but if you think a little bit, it's kind of obvious, because all of them are the reciprocal. So what happens with a reciprocal function? As the denominator gets bigger, the value of the function, of the fraction, becomes smaller. As the denominator tends to 0, the value of the fraction tends to infinite. And that's what you see here. Every time the cosine tends to 0, so for example, when you have the cosine of pi over 2, cosine of minus pi over 2, cosine of 3 pi over 2, all of these are going to yield a value that tends to infinite. That's why you cannot see here very well, but let me zoom in. You have here these asymptotes on these particular values, and the function and the fraction, the second, will either tend to infinite on the positive side or infinite in the negative side. You can try it out on your calculator by plugging in here values that are very, very, very close to these. So pi over 2 minus 3 minus pi over 2, 3 pi over 2, etc. And you'll see that the value of the second will tend to either plus infinite or minus infinite. Particularly when the value of the cosine is 1 or minus 1, that is in 0 degrees or in pi, the value of the second is also going to be 1 or minus 1. So cosine of 0 is 1, for example. 1 over 1 is 1. This means that the second of 0 is also 1, as you can see over here. By the way, this is a horrible drawing. This should look like that. For some reason, they are not together. But anyway, the point should be the same for the cosine and the second on the once you start drawing the shape. Same thing goes for the sine, right? Again, as the value of the sine tends to 0, the value of the cosecant will tend to infinite, either positive or negative side. As the value of the sine tend to minus 1 or 1, so on pi over 2 or minus pi over 2, the value of the cosecant will also have these particular values. For the tangent, it's the same thing. By the way, if this is 1 over the tangent, and if the tangent is the sine of the angle over the cosine of the angle, the cotangent is going to be the cosine over the sine, all right? But in relation to the shape, the tangent is a little bit different. Actually, it's completely different from the other two. But the same approach is followed over here. As the value of the tangent tends to 0, the value of the cotangent tends to infinite. When is the tangent 0? The tangent is 0 in 0 degrees, in pi, etc. So here, in 0 degrees, in pi, in minus pi, in 2 pi, you'll have asymptotes. Here on green, you have the original tangent. And you see that the shape of the cotangent, they will tend to either minus infinite or plus infinite on these values. 0, minus pi, minus 2 pi, pi, 2 pi, etc. As the value of the tangent tends to infinite, then the value of the cotangent will tend to 0. So every time you see here the green function, the tangent, tending to infinite, then the value of the cotangent will be 0. All you have to understand here, this is the good news about these three functions, is that all you need to understand is the original functions, sine, cosine, and tangent. You need to understand what the reciprocal function is, and with that in consideration, you can picture the shape of the functions yourself. Solving equations, again, involves you transforming the new functions into the old ones, and then solve as usual.